Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Faisal bin Hazry. Today, we will present communication principle for Mission 3 assessment. Topic we will cover is pulse modulation, multiplexing and signaling system 7. Firstly, pulse modulation. Pulse modulation is a type of modulation in which signal is transmitted in the form of pulse. It can be used to transmit analog information. In pulse modulation, continuous signals are sampled at regular intervals. Pulse modulation can be classified into two major types, analog and digital. Analog is indicate of sample amplitude in infinity variable, and digital indicate sample amplitude at the nearest predetermined level. Frequency range. The human can hear frequency range from 20 Hz into 20 kHz. To encode voice, we only need to encode enough to generate a passable digital reproduction of voice to make the voice audible at the receiving end when converting analog to digital. In telecommunication, the voice frequency band sampling is 300 Hz to 3400 Hz for voice frequency band. Sampling rate. Sampling rate is the number of samples of audio taken per second, measured in Hz or kilohertz. In digital encoding, the goal is to optimize the sample rate by making it as low as possible, with still maintaining a reasonable digital reproduction of the voice. The higher sample rate technically leads to more measurement per second and a closer recognition of the original audio. But if too high sample rate, it will capture extremely high and extremely low of spectrum where listener can even hear. This means that if too high sampling rate, it will take more space for music that doesn't have noticeable improvement in sound. Next is pulse code modulation. Pulse code modulation is a method that is used to convert an analog signal into a digital signal. Pulse code modulation is in a binary form, so there will be only two possible states, high and low. We can also get back our analog signal by using demodulation. The pulse code modulation process is done in three steps: sampling, quantization, and coding. Next is bit depth. Bit depth is the number of bits of information in each sample. High bit depth is needed to have more accurate recording. When a signal is sampled, it needs to store the sample audio information in bits. It is where the bit depth comes into place. The bit depth determines how much information can be stored. A sampling with 24-bit depth can store more information than 16-bit depth. Next is Nyquist theorem. The sampling theorem can be defined as the conversion of an analog signal into a discrete form by taking the sampling as a twice the input analog signal frequency to ensure the accurate digital reproduction. Example, a sound signal with bandwidth of 20 kHz need to rate above 40 kHz. Next is Nyquist theorem. The sampling theorem can be defined as the conversion of an analog signal into a discrete form by taking the sampling as a twice the input analog signal frequency to ensure the accurate digital reproduction. Example, a sound signal with bandwidth of 20 kHz need to rate above 40 kHz.
Hi, I am AMIRUL and I will be explaining to you about multiplexing. Multiplexing is a process of transmitting multiple signals simultaneously over a shared medium. The main objective is to increase the capacity of a transmission channel and utilize bandwidth more efficiently. Multiplexing is divided into two parts, which is analog multiplexing and digital multiplexing. For analog multiplexing, there is frequency division multiplexing (FDM) and wavelength division multiplexing (WDM). For digital multiplexing, there is time division multiplexing. Frequency division multiplexing. FDM is used for dividing the frequency spectrum of bandwidth channel into many smaller individual bandwidth communication channel. It is done by these steps, which is the total bandwidth is divided to a set of frequency bands that do not overlap. Each of these bands is a carrier of a different signal that is generated and modulated by one of the sending devices. The frequency bands are separated from one another by strips of unused frequency called guard bands to prevent overlapping of signals. Wavelength division multiplexing is a fiber optic transmission technique that enables the use of multiple light wavelengths to send data over the same medium or channel. It is done by the data flow of each input stream is divided into units. One input unit corresponds to one output unit and is allotted an output time slot. During transmission, 1 unit of each of the input streams is allotted one time slot. And lastly, for time division multiplexing, it is a method of transmitting and receiving multiple independent signals over a signal transmission channel by dividing the time frame. It is done by optical signals from different sources or transponders are combined by a multiplexer, and the combined signal is transmitted via a single optical fiber strand.
Hello everyone, my name is IBNUFAYYADH ADIWANGSA, and now I will present to you about Signaling System 7 or SS7. What is the definition of SS7? SS7 or Signaling System 7 is an international telecommunication protocol standard that defines how the network elements in a public switch telephone network exchange information and control signals. It is used to perform telecommunication all over the globe and was developed in 1975. There are two types of Signaling System 7. The first one is in-band signaling. In-band signaling or channel-associated signaling is how we traditionally place calls across trunks. Basically, we send the dial pulses along the same channels as the voice. This is low cost as the same network is used for voice as signaling, but it is also vulnerable to hacking. In addition to sending our dial pulses, we are also using trunk circuits to make calls, even if the called party is busy. If we can send signaling separately, then we only use a trunk when the called user is available. And the second type is out-of-band signaling. Out-of-band signaling, or common channel signaling, provides a separate signaling network to the voice network. SS7 optimizes the use of the network and increases customer revenue. With common channel signaling, it becomes possible to exchange signaling information without first seizing a voice channel, leading to significant saving and performance increases in both signaling and channel usage. Also, it's more secure as customers cannot get access to the separate signaling system. With SS7, we get new services such as call forwarding, voice email, call writing, and busy callback. Thank you very much.